Welcome to the deep dive. Today, we're tackling, well, maybe the ultimate question. Is this reality everything you see, hear, feel? Is it all just a really, really advanced computer simulation?
It sounds like something straight out of a movie, doesn't it?
Exactly. But it's actually a serious topic now in philosophy and even some corners of science. Thinkers like Nick Bostrom, even figures like Elon Musk, they're talking about this.
It's moved beyond just pure speculation.
Right. So our mission today is to really unpack this. We'll look at the best arguments for the simulation hypothesis and also the arguments against it.
We'll touch on the physics, the philosophy, maybe even what it means for, purpose.
And we'll use Nick Bostrom's famous simulation argument as our starting point. It's this kind of trilemma, basically.
Yeah.
One of three pretty wild propositions has to be true. So let's dive in.
Okay.
So this whole idea, it often kicks off with a prediction about the future, about where technology might go. How does that set things up?
Well, it starts with thinking about what a truly technologically mature civilization could do. We call them post-human.
Posthuman, okay.
Yeah. And the argument suggests these civilizations will have just unbelievable amounts of computing power, like planet-scale computers.
Planet scale.
Seriously, capable of something like 10 to the power of 42 operations per second. It's a number that's hard to even wrap your head around.
So way beyond anything we can imagine now. And what would they do with all that power?
That's the million-dollar question, is it? Or maybe trillion-dollar. One possibility is running what are called ancestor simulations.
Simulating their past, like us.
Pretty much.
Ah,
Really detailed simulations of their evolutionary history, people like their ancestors, or maybe just people like their ancestors. And here's the mind-blowing part. A single one of these planet-sized computers could simulate the entire mental history of humankind, like all thoughts ever had, using less than a millionth of its power for just 1 second.
Okay, wait, that's staggering. But simulating minds, that gets us to consciousness, right? Can a simulated being actually be conscious?
That's absolutely crucial. And it leans on an idea from philosophy of mind called the substrate independence thesis.
Substrate independence, meaning
Meaning, consciousness or mental states in general might not need a biological brain like ours. The substrate, the physical stuff it runs on, might not matter.
so silicon chips could, in theory, support consciousness if they're running the right software or the right processes.
That's the idea. As long as the computational structure is complex enough, the underlying material, whether it's carbon or silicon, might be irrelevant to the experience itself.
Is that really widely accepted, though? The idea that consciousness isn't tied to biology feels like a huge claim.
It's definitely debated, like most things in philosophy of mind. But it's a common enough assumption in these discussions to let the argument move forward. Even if, say, chemicals play a role, the argument goes, they do so by affecting the computation. So the principle kind of holds.
Okay, so let's assume for a moment that posthumans could run these simulations and the beings inside could be conscious. Where does that take us?
Well, think about the numbers. If even a relatively small fraction of these advanced civilizations decide to run ancestor simulations, the number of simulated minds, simulated people like us, could just vastly, overwhelmingly outnumber the original biological minds in the universe.
Right. Suddenly, there are potentially billions, trillions, way more simulated consciousnesses than real ones.
Exactly.
So how do you figure out which kind you are? If you're just, waking up one day, how do you know if you're biological or simulated?
This is where Bostrom introduces what he calls the bland indifference principle.
Bland indifference. Okay.
It basically says, look, if you know that some fraction X, let's say 99% of all observers with experiences like yours are living inside simulations,
Yeah.
and you don't have any specific information pointing to you being biological or simulated,
Uh-huh.
you should assume your probability of being in a simulation is that fraction X.
So if simulated minds vastly outnumber biological ones, the odds are overwhelmingly that you are one of the simulated ones.
That's the statistical punchline. If X gets very close to 1 or 100%, then you should probably conclude you're in a simulation.
I know Elon Musk has talked a lot about this. What's his take? Is it similar?
Yeah, Musk leans heavily into that third part of Bostrom's trilemma, that we're almost certainly in a simulation. His logic is very straightforward.
How so?
He says, just assume any rate of technological improvement, even a tiny one, like 0.1% per year. Eventually, video games, virtual reality, will become completely indistinguishable from base reality.
Okay, makes sense.
So he argues either that happens, where
Yeah.
civilization collapses before we get there, or We're likely already in one of those indistinguishable simulations created by someone else.
And he had that interesting idea about why they'd simulate us, right? Something about base reality being boring.
Right. He suggested maybe the real reality is quite dull, and simulations are run to kind of distill the interesting bits, like editing a long movie down to the exciting parts.
Okay, that whole line of reasoning, the post-human power, the statistics, it's pretty compelling in a way. But what about the hard science? Can physics put the brakes on this idea?
Ah, yes. Physics definitely has something to say. It brings things back down to, well, physical reality. The core principle here is that information is physical.
Meaning you can't just compute for free. It takes energy, resources.
Exactly. Every calculation, every bit flipped requires actual energy, takes up space, takes time. So we can use physics to check if simulating a whole universe or even just Earth is actually plausible.
And what does that calculation look like? Can we actually simulate Earth?
Well, let's look at the information first. There's something called the holographic principle. It suggests the maximum information you can pack into a volume of space is related to its surface area, not its volume.
Okay, a bit counterintuitive, but it gives us a number.
It gives us a lower bound, a minimum estimate. And even using that conservative estimate just to start a simulation of planet Earth down to the smallest possible scale, the Planck length, you need about 9.8 times 10 to the power of 74 bits of information.
Which means how much energy?
It means an energy input comparable to the entire rest mass energy of a globular cluster, basically.
Yeah.
The energy locked up in millions of stars, just to boot it up.
Wow. Okay. Just to start it, does it keep costing that much?
Pretty much. Roughly, that same enormous amount of energy has to be managed, dissipated as heat, for every single tiny step forward in time in the simulation.
Every time step.
Every time step. So after maybe 1 million steps, which is nothing on a cosmic scale, the total energy needed is like the energy equivalent of the entire Milky Way galaxy.
Of the whole galaxy.
Yeah, and if you assume more realistic temperatures for the computer, not absolute zero, maybe something like around a black hole, the energy cost jumps by another factor of 10 million. It gets physically absurd very quickly.
So the energy costs seem prohibitive, to say the least. Are there other physical constraints, things we observe?
There are. One really interesting one comes from high-energy neutrinos. These tiny particles come from deep space, extragalactic sources, and they travel right through the Earth.
Okay.
The fact that we can detect them and they interact in certain ways implies that any simulation of Earth, even a fairly low-resolution one, has to be able to accurately represent physics down to incredibly tiny scales. About 10 to the minus 21 centimeters.
That's incredibly small. What does that imply for the simulation?
It forces the simulation to have an incredibly short minimum time step, like the smallest possible tick of the simulation's clock, about 4 times 10 to the minus 32 seconds.
So not just an energy problem, but a speed problem too. The simulation has to run impossibly fast.
Exactly. To process all the information needed for even that low-res Earth simulation and update it every 10 to the minus 32 seconds in anything like our real time,
Yeah.
you'd need to be converting more energy into computation per second than exists in all the stars and all the galaxies in the entire visible universe.
Okay, so the physics seems to suggest simulating even just our planet in a way consistent with what we observe is, well, basically impossible.
The conclusion from that line of research is pretty stark. It would take geologically long timescales just to run a short simulation, making it entirely implausible for any purpose.
Now, separate from the physics, there are also critiques aimed at the core assumption about consciousness, right? That it can be simulated at all.
Yes, that substrate independence idea we talked about. It has philosophical challengers.
What's their argument?
Some philosophers argue that consciousness, our subjective experience, qualia, intentionality, what it feels like to be us, simply cannot emerge from purely physical computation, no matter how complex.
So they're saying it's fundamentally different from information processing.
So essentially, yes. They'd say it's metaphysically impossible to reduce mind to matter in that way. It directly challenges the assumption that silicon could host consciousness just like a brain does.
And what about the statistical argument, that bland indifference principle? Do people take issue with that too?
Oh, yes. That gets pushback. There's a kind of famous counterargument that goes something like this.
Okay.
Most people in the world have the feature, not being me. Based on statistics, should I therefore conclude that I am probably not me?
Huh. Right. It shows the potential absurdity of applying that kind of statistical indifference to your own unique position as an observer.
Exactly. It suggests maybe that principle isn't the right tool for figuring out if you, specifically, are in a simulation versus the real world.
Okay, so we have philosophical doubts, massive physics problems. Are there any other scientific roadblocks, maybe from quantum mechanics?
There are potential ones, yes. Some research into simulating quantum systems using classical computers has hit walls.
How so?
Well, there's a technique called quantum Monte Carlo used to approximate quantum behavior. But studies suggest this classical method is fundamentally incapable of fully simulating a quantum computer itself.
And if you can't simulate a quantum computer?
Then simulating an entire universe, which operates on quantum rules at its most fundamental level, seems like an even bigger, maybe impossible, hurdle for any classical simulation run by our hypothetical posthumans.
Let's switch gears a bit. If, hypothetically, we were in a simulation, could we ever tell? Would there be signs? Glitches in the matrix, so to speak.
That's a fun thought experiment. Some theorists, like the physicist John Barrow, suggested maybe a simulation wouldn't be perfect.
Like bugs in the code?
Kind of. Maybe small computational errors could build up over time, and the simulators would have to issue patches. We might see this as sudden, unexpected changes in experimental results or even tiny shifts in the fundamental constants of nature.
So the laws of physics suddenly behaving slightly differently.
Potentially, though we haven't seen anything like that definitively, of course.
And people talk about more everyday glitches too, right? Like seeing strange repetitions or things freezing. But what about scientific phenomena that look suspicious?
The double slit experiment is often brought up in this context. You know how quantum particles seem to behave like waves, going through both slits at once, until you try to measure which slit they went through, then they act like particles and pick one.
Yeah, it's famously weird.
Some interpret that weirdness as evidence the simulation is conserving resources. Like, reality isn't fully rendered until someone looks at it, just like a video game doesn't draw things you're not looking at.
Saving processing power. Interesting. And then there's that thing with the sun and the moon.
Ah, yes. The fact that from Earth, the sun and moon appear almost exactly the same size in the sky. It's why we get perfect total solar eclipses.
Which is quite a coincidence.
A remarkable coincidence. Some see it almost as too neat, too aesthetically pleasing, perhaps hinting at design, like an Easter egg left by the simulators. Others, of course, point to natural explanations like the anthropic principle or orbital mechanics like tidal locking. But it does make you pause.
It really does. And, you know, this whole idea, simulators creating universes, maybe nested universes, it starts to sound almost religious in a way.
Absolutely. It leads directly to what some call a naturalistic theogony, a theory of the origin of gods, but grounded in physics and computation.
How does that work?
If you imagine simulations within simulations within simulations.
An infinite regression.
Potentially.
Right.
Each level down, the simulators would likely be more intelligent, have more computational power than the beings in the simulation they're running.
So as you go deeper, the creators become more godlike relative to the created.
Precisely. You can see parallels to traditional arguments for God, like the cosmological argument. Maybe there's an ultimate base reality, the uncaused cause, which could be thought of as pure hardware or an infinite computer.
And the design argument, too.
Yes. The intelligence designing and running the simulation could be seen as the undesigned designer of everything within it. It maps surprisingly well onto some theological structures.
If we take this idea seriously, even just hypothetically, what does it do to concepts like an afterlife or the meaning of our lives?
Well, an afterlife suddenly becomes technologically plausible, doesn't it?
How so?
The simulators could easily record everything about us, our minds, our experiences, and then just reboot us in another simulation. Or maybe even upload us into their own reality.
Like computational resurrection.
Exactly. There's even the idea of serial resurrection.
Yeah.
We live successive lives, moving up through different simulation levels, getting closer to the ultimate reality or the ultimate simulator, the God level.
Oh, wow. Okay. And purpose. Why would they bother simulating us in the first place? Is it just cosmic entertainment?
Maybe partly. Some propose an aesthetic theodicy. The idea is that maybe our universe isn't fine-tuned for life specifically, but for the emergence of complexity and interestingness. Yeah. Drama, beauty, the pursuit of knowledge, discovery. Maybe the simulators value these things. Maybe creative intelligence is just fundamentally interested in interesting things. So perhaps the point of it all is simply for us to lead an interesting life.
Lead an interesting life. That's a purpose I can get behind, simulation or not. Now, there's also a model trying to bring quantum mechanics into how a simulation might actually work, right? The advanced observer model.
Yes, there's an attempt to integrate everything, quantum physics, relativity, the simulation idea. It suggests there's a sort of central server that transmits multimedia frames to each observer, creating our reality frame by frame, like a movie. But a movie where the observer plays a key role.
So reality isn't continuous, it's made of discrete frames, and our perception ties into that.
That's the core idea. It proposes different levels of reality, like R0 for the basic quantum level, R1 for complex quantum stuff, R2 for our everyday macroscopic world, each with its own frame rate.
Frame rate, like in video.
Sort of. These frame rates would supposedly determine how we perceive time and space. Faster frame rate means finer time resolution. It even tries to explain things like time dilation and relativity as effects of these frame rates.
That's ambitious. Does it have any practical implications?
The proponents suggest it might. For instance, understanding these observer capabilities could potentially lead to better error correction in quantum computers or more secure quantum communication methods. It's still quite speculative, though.
All right, after exploring all these complex arguments for and against and the wild implications, I heard Neil deGrasse Tyson had a perspective that kind of flipped the odds for him. What was that?
Yeah, it's a really neat bit of reasoning. Tyson looked at all these hypothetical simulated universes, and he noticed they all have one thing in common. The beings inside them eventually develop the power to simulate universes themselves. That's part of the premise. But then he asks, do we have that power right now?
Well, no, not even close to simulating conscious beings in a universe.
Exactly. So if we don't have that power yet, it means we're either the one original base reality universe,
The start of the chain.
or we happen to be the one civilization in the potentially long chain of simulations that hasn't reached that simulation creating stage yet. We're still evolving towards it.
So instead of the odds being astronomically high that we're simulated,
It suddenly looks more like a 50-50 chance.
yeah,
Either we're the originals or we're pre-simulation capable simulants. It drastically changes the statistical picture.
that is a clever twist. And doesn't Bostrom himself have a point about how we might actually find out for sure?
He does. It's related.
Yeah.
Bostrom suggests that if we ever get to the point where we are about to switch on our own complex ancestor simulations.
The ones we were talking about earlier.
Yes. The moment we're ready to hit run on those, that would be incredibly strong evidence against the first two parts of his trilemma, that civilizations die out or aren't interested.
Leaving only the third option.
Leaving only the third option, that we are almost certainly in a simulation ourselves. Because if we can do it, it implies countless others likely already have.
So the act of creating our own simulation would paradoxically be the strongest sign we're living in one.
That's the idea, a kind of self-revealing prophecy.
Okay, so let's say, after all this back and forth, we lean towards thinking, maybe we are in a simulation. How should that change anything? How should we live? Do we look for cheat codes?
You know, it's interesting, but the consensus among most who ponder this is probably not much should change.
Really? Why not?
Because even if it is a simulation, our best bet for predicting what happens next, for navigating this reality, is still using the tools we have. Science, reason, past experience, common sense.
We don't know the simulator's rules or motives, so acting randomly doesn't help.
Precisely. Unless they decide to intervene directly, a giant "you are in a simulation" pop-up window appears in the sky, or they upload us somewhere else, we probably wouldn't know, and our current physics and social models are still our best guide.
And the whole question of free will inside a simulation, that's another philosophical rabbit hole, I imagine.
Oh, absolutely. Does being simulated preclude free will? Or could it be programmed in? That's a whole other deep dive.
So, what a journey. We've looked at the simulation hypothesis from, well, seemingly every angle. The futuristic tech, the mind-bending statistics.
And then the serious pushback from physics. The energy costs, the processing speeds needed seem just impossible based on our current understanding.
Plus the philosophical questions about consciousness, the critiques of the statistics, the potential quantum limits.
We even touched on potential glitches, the surprising parallels with theology, and these ideas about quantum frames of reality.
And it all circles back to that core trilemma from Bostrom, doesn't it?
It really does. Either advanced civilizations go extinct before they can simulate, or they lose interest in simulating their past, or we are almost certainly living in one right now.
And the fact that one of those seemingly unlikely things must be true is, well, it's kind of mind-blowing on its own.
It forces you to confront some very fundamental assumptions about reality and our place in the cosmos.
Absolutely. So maybe the final thought for you, our listener, is this. Whether this reality is the base level or just one simulation among countless others, does it change the value of our quest to understand it?
Our drive to explore the universe's laws, the nature of consciousness, the sheer complexity around us that seems profoundly important, regardless of the ultimate substrate.
What new discoveries, what new philosophical insights are waiting just around the corner as we keep asking these big questions about the true nature of our reality? Something to ponder.